This is Chapter 8, Lecture number 2. We start off with this page on naming common acids. We're not going to really do much with this now because we have a unit on this in the second semester. But acids are compounds that produce hydrogen ions. Hydrogen ions are H plus ions. And this whole page is about naming acids, but we're going to skip down to the bottom and just look at how to name these acids. To name them, we're going to use table K. So if we look at table K, we have two kinds of acids here. One is just hydrogen and an element, in which we just say hydro instead of hydrogen. And chlorine becomes chloric, not chloride. So HCl is hydrochloric acid. The other type of acid has an oxygen in it, in which case we will just look up the name for now in table K. So if we look at our notes, hydrochloric acid is HCl, and you really need to have table K in front of you. Nitric acid is HNO3, so we're just looking on table K. Sulfuric acid is H2SO4. Acetic acid is the one that has two possibilities. It's also called ethanoic acid. Hydrobromic, like hydrochloric, is HBr, and hydrosulfuric, like hydrobromic, should be HS, but S's charge is -2, H is +1, so it's H2S. And that's all we're going to do with acids for now. So our big learning for today is going to be on the page that starts with structural formulas. The structural formula we practiced the first lecture is just dots and dashes to represent two-dimensionally how the molecule appears. We have a set of rules that we follow for drawing these Lewis structures for molecules, and what we're going to do is just go straight to the page where we start drawing them. So we're going to start with number 1, HF, and the first step is to count valence electrons. So hydrogen's group 1, fluorine is group 17, so this has 8 valence electrons. That's always the first step. The next step is we draw a basic molecule, and remember, a molecule is covalently bonded, so it's a sharing of electrons. So we're going to show with a dash the shared pair of electrons, one from the H and one from the F. That dash takes care of 2 of the valence electrons. So we have 6 left. We take the 6 left, and we know fluorine, to follow the octet rule, has to have those 6 electrons. So now hydrogen is touching 2, and fluorine is touching 8. So that's basically it. So now let's just go ahead and pound through a few of them. Number 2, NH3. Step 1, count valence electrons. N is group 15, so it has 5. Each H has 1. So again, there's a total of 8 valence electrons. The first atom is usually the one found in the center of the molecule. So here's our N. We have 3 H's, which we're going to attach with the dashes, which represent the 2 electrons that are shared. Each dash 2 electrons. Since we have 3 dashes, that takes care of 6 of the electrons. We have 2 left. We have to distribute them so that the octet rule is followed. So number 3 is PCl3. Step 1, count the valence electrons. Phosphorus is group 15, chlorine is group 17, so 7 times 3 is 21, plus the 5, 26 valence electrons. Usually the thing is in the front, is in the middle. Each dash represents 2 electrons, so we've used 6 out of the 26. We have 20 left to distribute. So we'll put 6 here, 6 here, 6 here. So now chlorine has all obeyed the octet rule. 6 times 3 is 18. There's 2 left we have to distribute for the 20, and we'll put those on phosphorus. The fourth one is water, H2O. Water is unique, water is different, but we still start with valence electrons. Each H has 1, oxygen has 6, so there's 8 valence electrons. Here, oxygen is in the middle with an H on both sides. Each dash counts for 2 electrons, so that takes care of 4. We have 4 electrons left to distribute, and they will go on the oxygen, so it has 8. Also, water is what we call a bent molecule. So actually the hydrogens are at right angles to each other, which we'll talk about more in class. Number 5 is CH4. Count valence electrons. There should be 8. Carbon is in the middle, surrounded by the 4 H's. Remember, hydrogen only has to touch 2 electrons for it to be stable. Everything else wants 8, for the most part. So here carbon is touching 8 electrons, 2 electrons from each dash. 6, NH4+. Now we have a positive ion. We lost an electron because of the positive sign, so we have to account for that when we count valence electrons. Nitrogen has 5, each H has 1 for a total of 9, but we lose 1 because of the plus sign, so we have 8 valence electrons. Nitrogen is in the center, surrounded by the H's, and that takes care of the 8 valence electrons. And nitrogen's touching 8, each H is touching 2, and that's what we want. We enclose the molecule, or the ion, in a bracket with a plus sign to indicate it's an ion. Number 7. Now we have SO3, 2 minus. We count up the valence electrons. Sulfur and oxygen are both in group 16, so they have 6. There's 4 of them total for 24, plus the minus 2. We have 26 valence electrons. Sulfur is in the middle. We put our 3 oxygens. That takes care of 6 of the 26. We have 20 left to distribute. 2, 4, 6, 8, 10, 12, 14, 16, 18, and then sulfur needs the last 2. So we distributed the 20, and everything is touching 8. Because it's an ion, we put the SO3 in brackets with a minus 2 charge. So I know that was a lot for today, but we'll discuss it more in class, and we'll work this out. For now, that's it for tonight, and we will see you tomorrow.